What's up, people? My name is Kian. I'm going to be talking about curvature and refraction correction for surveying. And this is for the class Civil Engineering 283, Surveying and Geomatics. Going to share my screen right here. Okay, curvature and refraction. So what is curvature and refraction? Well, curvature is just the curve of the Earth, right? And we can see on this graphic here on the right that as your line of sight leaves your system, there's a curve and there's a difference between your line of sight and the actual physical place where these things are that you're seeing. Um, and yeah, this is just something that we need to correct for. Going to this graphic, you can see one important concept is that as your line of sight leaves your system, the difference between that and the curvature of the Earth is exponential, right? There's a big and then an even bigger difference as it moves away. Refraction. Refraction is the other half of this equation, and it's essentially when light waves interact with the medium that they pass through. The variables we'll be looking at are humidity, pressure, and heat. But you might think these variables differ pretty often throughout a day. You're right, heat does change. In the morning and evening, it's cool near the surface and light refracts upward. And in midday, when it's really hot and it's humid, light retracts in more of a downward angle. And that's actually what creates mirages, right? That light is just bouncing all around. Another little quick fact is that it's actually why stars twinkle, right? The light particles um, and those light waves from the star pass through, gas in outer space. They pass through heat on Earth. And it really just like messes with the direction of the light wave, right? And so stars kind of fade in and out. Pretty interesting. All right, so let's give you all a math problem. So I chose the rail runner um, because I like to imagine that there's an Earth, and then the rail runner, a big train, is like having to bend vertically to go around the planet. I think it's just a fun visual. And so we have one car is about 68 feet for five cars on a single train. We have about 340 feet, and we'll use these equations to get into it. So for our key here on the right, we have D equals the horizontal distance, R equals the Earth's radius, and K is the coefficient of refraction. Just a general coefficient for all those variables that we talked about. We have the curvature correction at negative d squared divided by 2r. Refraction correction d squared over 2r times that coefficient, and then our combined equation. And so when we plug and chug, use 340 feet as our distance of that rail runner, the curvature correction comes out to negative 0.0027 feet. And for the refraction correction, using that same distance, 340 feet, our correction comes out to 0.00036 feet. And we add those two together, it comes out to a difference of negative 0.00234 feet. So really not that much. Really not that much that the manufacturers have to account for. But there's still a difference nonetheless. I feel like that raises a question. If that's not really significant, then what is? Well, I made a table here. And on the right, we can see the different distances and how how much that is from the Earth's curve. Starting from the top, um, at 200 meters, we have a difference of 0.8 millimeters, which is really not that much. But like I mentioned, the difference is exponential, right? And so when we start getting out to numbers like 5 kilometers, the difference of 0.2 meters is very significant. And it really matters for when people are surveying or construction or designing construction plans. Um, and at 50 kilometers, there's a difference of 20 meters, which is really quite significant if we that's about it that I have for y'all. Um, a quick recap, right? We learned what the curvature and refraction mean. Um, and I gave you some equations to account for that for when you're surveying, and a few examples, right, about twinkling stars and the like. So I hope you enjoyed my video. Thank you for watching.